Let us begin with the criterion B and C. So this problem is on gravitational potential energy on inclined planes. A class of MYP students has been asked to perform an experiment to investigate variables that affect the way the moving objects behave. Okay. So one student knows that the energy changes takes place as the objects slide down the ramps. Okay. She decides to investigate the motion of a sliding wooden block using a ramp and the effect the height of the ramp has on the distance traveled by the wooden block after it reaches the bottom of the ramp. What she does is actually, this is the ramp over here, and she can lift the ramp upwards. Okay, so initially it is at a height of 35 centimeters. You put the block over here, block will now start sliding like this, and when it comes here, it will now start sliding like this also here. Okay, probably this might go until this much. Okay, when the ramp is kept at a height of 35 centimeters. Now, the next one, let us say for example, when the ramp is being pulled upwards, you see the angle made by the ramp with the horizontal is larger, and what will happen to the object? Object will now try to move a larger distance, right? To a larger distance. Earlier it was traveling only until so much, now it is traveling until this much distance. Now, as we keep on lifting this one, so definitely this distance will also be larger. And there is something else also given here. See, this height 80 centimeters is not changing, which means what? So you see this was extending here, and here it is not extending, it's at the tip over here, which means that this distance is not changing. So this will always be a constant throughout the experiment. So I need not worry about the experiment distance. So I will be interested to find out what is this distance, how does this distance vary. Okay, so by just looking at the diagram, by looking at the question, so I have got some thoughts in my mind which I am putting it across currently. Now let us move further and read what else is there. Okay, so now it says she decides to investigate the motion of a sliding wooden block using a ramp and the effect the height of the ramp has on the distance traveled by the wooden block after it reaches the bottom of the ramp. After, which means what? You're not interested into this length or this length because these are all constant. We are interested only into this particular length. Okay. Now next is the ramp being used is 80 centimeter long, and it can be set to any height between 35 to 60 centimeter. The block has a mass of 0.25 kg. Block has a mass of 0.25 kg, which is 250 grams, and this is 80 centimeters. What is the question over here? The question is select the statement below that best describes the main energy transfer that takes place as the block slides down the ramp. Why does the block slides down the ramp? What is the energy that is happening? Who gives the energy, and how is the energy being utilized? That's the question. So towards it, kinetic energy is transferred to GPE, gravitational potential energy. No. Okay. See, the kinetic energy. What do you mean by kinetic energy? The energy possessed by an object because of the speed of an object, right? Now, where do you get the speed? You get the speed because there is an inclined plane. So when you have lifted this one upwards, now what happens? The object now starts sliding faster and faster, which means the height is larger, which means the gravitational potential energy is getting converted to kinetic energy. Which one is the right one? Gravitational potential energy is transferred to kinetic energy. So this is the right answer. So these are all incorrect ones. There is no elastic energy over here. There is no spring, so you should not use elastic energy. Then calculate the energy of the block when it is at a height of 60 centimeter. When it's at a height of 60 centimeter, what is the height here? See, at a height of 60 centimeter, when the block was at this position, what is the energy of the block? Energy is purely due to potential energy. What is the potential energy given by is equal to mgh? What is the value of m? 0.25 kg. What's the value of g? 10. What is the value of height? 60 centimeter. It is 0.6 meters, right? So which should now be, let us calculate the value and see what do I get here. 0.25 multiplied by 10 0.6 give you 1.5. Thus the energy here is 1.5 joules. Okay, so energy here is 1.5 joules. 1.5 joules. Now remember, this question is criterion A, and this question is also criterion A. Okay. So sometimes what happens is in the question there should be criterion A, B, and C together. But this this question is something like this. In your exam also, you might have a question, okay, very similar to this, where you have a criterion A, B, and C, and D to be done. Okay, now let me look at the next one. State the question that could be answered in the expert. Now comes your criterion B, design of an expert. So, what is the question that you can state? What is the question you can state? See, now if I keep my height here 35 centimeter, now this could move until here. If I keep it like this over here, this could move to a distance here. If I keep on increasing the height like this, then what can happen? The distance moved will be larger and larger. This is what I'm going to investigate. So clearly I can say my independent variable is nothing but your height. And what's a dependent variable? This could be your dependent variable. Now with this we need to ask the question. Okay, how does this depend on that one? Okay, so how do I write? I can now write how does. Okay, so how does the increase in height? Should I write increase in height? No. We'll write this as how does the release of an object in an inclined plane, what should do? It will affect the distance traveled by it from end of the ramp. Right? This question appears to be a good one, so we can very clearly proceed. Okay, now, so next is, see here, what does it tell you? It tells you, see, whenever we ask a question like this, we don't need your reasoning, because it's only for 1 mark over here. And what you need to connect between your independent variable and your dependent variable, and that should be an open-ended question. Okay, now next, formulate and explain the hypothesis that this question tests. What is the formulation? Formulation means you need to formulate what is your hypothesis, put across the hypothesis, which means now the open-ended question becomes a closed-ended question. Which means what? You are now predicting what can happen, and then you are proceeding, and then you are going to explain why does this hypothesis seem to be true, what is the reason behind it. Now, what is the formulation? The formulation tells you if the height of the ramp increases, then the distance between the end of the ramp, should I write height of the ramp? I should write the height of the release, because there also we use the same height. The height of release of the object on an inclined plane. See, this much we have to write. If I don't write this, then definitely we are not going to get the mark. Okay, increases, then the distance between the end of the ramp to its stopping point also increases. Right? So what did you do in the earlier one? You just mentioned, okay, how does. Now in the second one, the formulate, what you are going to do? You are going to very conclusively state this is what is going to happen. Okay, next. So here also your independent and your dependent variable are seen to be there, and you are going to mention very clearly what is going to happen. Now you need to explain. How much marks is it? 3 marks will be 1 mark for this. Explain. What is your explanation for this? Now, first explanation you can say is that as the height of release increases, the potential energy of the object increases. Right? The second one, what happens? During its motion down the plane, this potential energy is getting converted to kinetic energy, thereby the speed of the object increases. Right. Third point, as speed increases, the stopping distance also increases. Now, how did I understand? How much should I write here? They asked me this question. See, this you have already answered. Where did you answer? In your criterion, you have already answered. See, it says, okay, how does the energy transfer takes place? I already put it across here. So I took this question from here, the first point from here. Second point, I calculated from here, which means what? The energy kind, the potential energy was much higher. And the third point here. Okay, so I just mentioned when I did this one itself, I mentioned, okay, so why does the, what happens exactly here? What happens to the potential energy? What happens to the kinetic energy? I mean, we did look into all of them. As a result of it, this idea came to me. See, every question in IB or MYP is in such a way that the solution for it is already somewhere being present. Okay, you are already writing that one. So only thing is, you should look at it carefully, understand, get the clue behind it, then start working on it. Okay, now identify the variables in the set. Once again, it is reflecting what you are writing there, right? So therefore, variables. What are the variables over here? What are the variables? Independent variable. What's the independent variable here? What's the independent variable? I already written. Height. Dependent distance, right? So therefore, we write down the same. Okay, that's why whenever you start working on a problem, what is required is that you need to first understand the problem. You need to split the problem into appropriate parts. Okay, if you're clear about it, 70% of your problem is only about understanding. Plus 30% is only reflecting. Okay, now independent variable. What's the independent variable here? It's the height of the ramp. Height of the ramp. Okay, just don't mention height of the ramp. Mention which is varied from 35 centimeter to 60 centimeter in steps of 5 centimeters. Okay, because you know we have so much observations, so you should write this. Now, where did I get this information? Once again, now let me go back to the beginning part here. So it says 35 to 60 centimeters is given here, right? So somewhere, see, when you are asked some question, so the examiner expects that you reflect on what is being given. See, the criterion B and C is in such a way that something like your comprehension in English. Okay, wherein something is already given, you just need to reflect on what is being given. Okay, but only thing is some amount of critical thinking is very essential, and some reasoning part is also essential, and that is where we do over it. So independent variable, as I always say, it should have at least 3 to 4 parts. The first part is what is your name of the variable. The second part is what is the range which you are going to vary. The third part is what is the steps in how you are going to vary. And the last part should be unit. But anyway, in every sentence over here, unit is mentioned as a result of it. You are right. It does explicitly mention this. You can write something like this. Okay. So do not just mention blankly as height of the ramp. That doesn't carry much weight. Then dependent variable. What's the dependent variable? Once again, go back to a diagram and understand that. Dependent variable, we measure this one. What is this now? The distance between the end of the ramp, the stopping point, right? So let us write out that also. So here is distance between the end of ramp and the stopping point. Stopping point measured using ruler in centimeters. You know, you have mentioned everything. In fact, you have not only mentioned the variable, you also mentioned how you are going to measure and what is the unit of this. Again, we assume that there are 3 parts. The first one is you are going to mention clearly what is your dependent variable, the name of the dependent variable. Then this is your first part. The second part, measured using a ruler. So what does this tell you? It the second part tells you about what is the measuring instrument you are going to use. Okay. Finally, I'm going to mention what is a unit. All the three parts are very clear. You should definitely get 1 mark. Okay. Never assume saying that okay, so 1 mark should I write so much. Okay. If you have more information, I will be very happy to correct you. Okay. The control variable. What is a control? Let us look at it once again. Are you changing this mass of this block? It's not changing. Then are you changing the plane? You're not changing. Now if at all, if you change this one or you change this one, what will happen? If you change this one, then definitely what will happen? So this will have an extra friction over there. So as a result of it, it could be a smooth one, it could be a rough one, so on. So the object may go farther, maybe lighter, maybe stopping at the initial itself. That's possible. Then you are also not going to change this. If you change this, let us say I double the mass of this, what can happen? If I double the mass of it, then you need to apply a larger force for it, right? So as a result of it, this may move, may not move also. So what is required? These two I always seem to be fixed throughout my experiment. It's not given anywhere. This is a critical thing. Okay, so you should know which ones to keep constant, which one should vary across. Let me go back here and let me write down. The first one is mass of the object. This will be kept constant. What is the value? 0.1 kg throughout the experiment. Okay. Then second one is the type of plank. Type of the plank, or I'm sorry, plank or the inclined plane, so that friction does not change. Friction does not change. Okay. Maybe you can put one more also. You can also say length of the incline. Because I am using something like, let us say, 40 centimeter incline. Now I replace this with the same wooden plank, everything the same. Instead of an 40 centimeter, I put something like 120 centimeter. What will happen? So keep on moving the same uniform speed, anything can happen. So therefore, that is not a proper one. So let us take length of the incline also as one of the control variables. Okay, next. Select one piece of equipment you would need to perform this experiment. What is that you need an equipment over here? It's already been given an inclined plane. Suppose we need ruler. Ruler I definitely need because that's what I'm going to measure it. So this is the right. Okay, rest of them I don't need. Okay. The lowest height the ramp can be set is to 25 centimeters. Outline why there is a lower limit for the height of the ramp. Okay, so the ramp that is being shown, he has kept this only at 35 centimeters. Now the question is, can I put it 10 centimeters also? Just like this little bit inclination like this. Why should it be like this over here? Yeah, this question. And the answer here is that when I keep it like this, there is a possibility that there is a gravitational force acts here. So why should the object actually slide? There is a gravitational force which is acting. It's now pulling it like this over here, otherwise it will not fall, right? And there is also a frictional force. If this gravitational component, okay, gravity actually acts downwards. This component of this gravitational force acts in this direction, then and it overcomes the friction, it will slide. Otherwise it won't slide. For example, if I have this object, if I have this as my inclined plane, I keep this object on top of it. So let's say for example, I have the remote, I'm keeping it over here. Is it sliding? It is not sliding. Same object, same mass, everything is same. What I do? I tilt it like this. What happened? Height was increased, it started sliding. Why did it slide? The reason is because the gravitational force increased, right? Gravitational force increased. Okay, so therefore now I should write something. I cannot show it directly. I should write. What should I write? It should be for 2 points. Outline. Outline is the command term. I should write. First one is gravitational force. I should not write gravitational force. I should write component of gravitational force acts along the plane, first one, reducing the height below 35 centimeters will not will make this component to be less than frictional force. Hence, object may not even begin the motion. Hence, a minimum of 35 centimeter height is recommended to initiate this motion. Right? The entire story has been done. I think only for 2 marks should I write so much? Start writing, get the ideas need to be evolved. It's always better to write. Yeah? Okay. Now describe the data that you will collect. What is the data? You have to mention. So what data will you collect? First, which means what? He is asking you the procedure. What is the procedure that you are going to do? The first one, what are you going to do? You're keeping the object on top of the inclined plane, and then you're not going to push it up, right? And then what you're going to do? You're going to keep it at a height of 30 centimeters. The object of mass 0.25 kg is kept at the topmost point of the plane. The inclined plane is initially set to 35 centimeters. The object then slides along the plane and stops at a distance on the ground. The distance between the stopping point and the end of the incline is, okay, I think this will be your second point. Okay. First point is this, second point is distance between the stopping point and the end of the incline measured using a ruler. That is the third point. The incline's height is increased by 5 centimeters, and the distance mentioned in step 2 is measured for every observation. Pre-trial carried out. More the number of trials is better. What do you mean by this? It means if I kept a 35 centimeter, I do 3 trials. I drop it here, 35 centimeter first time, it goes here, and it goes here and stops. I'm going to measure this distance. Then 35 centimeter once again. First time you did it, second time also I'm doing it. Then once again you are noting it down. Third time, once again you are noting it, right? So 3 times you are noting it down for every observation. Very, very important point. Okay, do not miss this. Okay, for every observation, populated table structured way. What do you mean by structured way? Structured way means you start with 35, then you go to 40, then you go to 45, then you go to 50, then 55. You're going it like this only. You're not going to do something like 35 you do, then suddenly you go to 50, then suddenly you come back to 40. No, you should not do it. Okay, systematically you should do it. Okay, so do it systematically, get the readings and populate that in the tabular form. That is very, very important. Okay, third point is also done. These are 4 marks. Getting 4 points. One more point. Last point. Last point is the average of the distances are calculated and the trend between the release height and trend between the release height and the stopping distance is okay. This is right so much. Okay, this will definitely give you full 4 marks. Right. So next comes Criterion C, which we will see tomorrow's class. Okay, but we will be continuing with the same problem. Thank you.